This week on the show, we have insights into TrueOS and Trident. We stop the evildoers with pf-badhost, a flashback to FreeBSDcon 99, OpenBSD's measures against the TLBleed. We play Morrowind, or you can play Morrowind actually on OpenBSD in 5 little steps. DragonflyBSD developers are shocked at the Threadripper performance and more in this week's episode of BSD Now. BSD Now, episode 261, FreeBSDcon Flashback, recorded on the 29th of August 2018. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And we're bringing you a fresh episode this week, as always. Headlines start this week with an insight into the future of TrueOS BSD and Project Trident. We haven't heard from them in a while, so we might as well check back a little bit. So this is from itsfoss.com. And the way we do it, I will read the It's Foss part, and Alan will provide the answers that the TrueOS folks were providing. So the article starts off, last month, TrueOS announced that they would be spinning off their desktop offering. The team behind the new project, named Project Trident, have been working furiously towards their first release. They did take a few minutes to answer some of our questions about Project Trident and TrueOS. And he would like to thank JT and Ken for taking the time to compile these answers. And so now it starts with It's Foss asking, what is Project Trident?
So Project Trident is the continuation of the TrueOS desktop. Essentially, it is the continuation of the primary TrueOS software that people have been using for the past 2 years. The continuing evolution of the entire TrueOS project has reached a stage where it became necessary to reorganize the project. To understand this change, it's important to know the history of the project known as TrueOS. So originally, Chris Moore created pf-badhost. That'd be more than 10 years ago now. And that was a desktop release of FreeBSD focused on providing a simple and user-friendly graphical experience for FreeBSD. pf-badhost grew and matured over many years, and during this evolution, many pf-badhost users began asking for a server-focused version of the software. Chris agreed, and TrueOS was born as a scaled-down server version of pf-badhost. So vanilla FreeBSD with some of the tools from pf-badhost, like the package manager and so on, but not the graphical part. In late 2016, more contributors and growth resulted in significant changes to the pf-badhost codebase. Because the new development was so markedly different from the original pf-badhost design, it was decided to rebrand the project. So one of the other big changes there was switching to being based on FreeBSD's basically cutting-edge version rather than the releases. So TrueOS was chosen as the name for this new direction for the pf-badhost project, as it had grown beyond providing only a graphical front to FreeBSD and was beginning to make fundamental changes to the operating system itself. One of these changes was moving pf-badhost from being based on individual FreeBSD releases to being based on the active and less outdated FreeBSD current branch to get drivers more quickly and so on. Other major changes were switching to OpenRC for service management and being more aggressive about addressing long-standing issues in the FreeBSD release process. TrueOS moved towards a rolling release cycle twice a year, which tested and merged FreeBSD changes directly from the developer version instead of waiting months or years for the release version. TrueOS was also deprecated and removed obsolete technology much more regularly, including dropping support for 32-bit and things like that. So as the TrueOS project grew, the developers found these changes were needed by other FreeBSD-based projects. These projects began expressing interest in using TrueOS as their base rather than FreeBSD. I think FreeNAS was one of the first ones in that case, which makes sense because if they're already funding the development of TrueOS, why wouldn't they use it for their FreeNAS appliances? So this demonstrated that TrueOS needed to again evolve into a distribution framework for any BSD project to be able to use. This allows port maintainers and source developers from any BSD project to pool their resources and use the same common source repository, while allowing every distribution to still customize, build, and release their own self-contained project. The result is a natural split in the traditional TrueOS team. There were two kind of natural teams that came out of it, those working on build infrastructure and FreeBSD itself, the core part of the project, and those working on end-user experience and utilities, the desktop part of the project. When the decision was made to formally split the project, the obvious question which arose was what to call the desktop side of the project, as TrueOS was already positioned as the BSD core OS distribution platform. The developers agreed the desktop side should pick a new name. There were other considerations too, one notably being that there was concern that if we continued to call the desktop project TrueOS Desktop, it would prevent people from considering TrueOS as the basis of other desktop-based distributions, or have the misconception that TrueOS was a desktop-focused OS, when really it's not anymore. It also helps to level the playing field to allow other desktop distributions like GhostBSD, which now uses TrueOS as its base, to still be a valid thing and not to have the TrueOS desktop be the only official desktop distribution of TrueOS or whatever.
Yep. And then it's first asked, what features will TrueOS add to the FreeBSD base?
Yeah, so TrueOS has already added a number of features to FreeBSD, including using OpenRC instead of the rc.d service management framework, switching to using LibreSSL in base, installing the Mozilla NSS root certificate bundle out of the box, and having a more scriptable installation using PC sysinstall. And you can see a full list of changes in the TrueOS repository, including the README.
Okay. And then they asked, I understand that TrueOS will have a new feature that will make creating a desktop spin of TrueOS very easy. Could you explain that new feature?
Historically, one of the biggest hurdles of creating a desktop version of FreeBSD is that the build options for packages are tuned for servers rather than desktops. This means a desktop distribution cannot use the pre-built packages from FreeBSD and must build their own and maintain a custom package repository. Maintaining a fork of the FreeBSD ports tree is a non-trivial task. There are 30,000 packages in there. TrueOS has created a full distribution framework, so now all it takes to create a custom build of FreeBSD is a single JSON manifest file. There is now a single source of truth for the source and the ports repositories that's maintained by the TrueOS team and regularly tagged with stable build markers. All projects can use this same framework, which makes updates trivial. So each project that wants to build their own desktop spin doesn't have to maintain their own package repo and have a bunch of servers building packages all the time and so on.
Oh, that's good. Do you think that the new focus of TrueOS will lead to the creation of more desktop-centered BSDs?
That's the hope. Historically, creating a desktop-centered BSD required a lot of specialized knowledge. Not only do people not have this knowledge all the time, but many of them don't even know what they need to learn so that they can start troubleshooting. TrueOS is trying to dramatically simplify this process and enable a wider open source community of experimentation, contribution, and enjoying BSD-based projects. Because you just make this one JSON file, it lets people who care about things like how the desktop looks and getting all the theming and coloring to better, to focus on that part and not have to, spend their time understanding make files. And I think that will result in
lower barrier to entry.
The right people spending the time on the thing they're good at. Instead of trying to have or having to have one person that's good at a bunch of these different things to be able to get a desktop or something.
Yeah, that's certainly interesting to see what comes out of that. And then it's first asked, what is going to happen to TrueOS Pico? Will Project Trident have ARM support?
So Project Trident will be dependent on TrueOS to have any ARM support. The developers have talked about the possibility of supporting ARM64 and RISC-V architectures, but it's not possible at this time. If more open source contributors want to help develop ARM and RISC-V support, the TrueOS project is definitely willing to help test and integrate that code. But at this point, maybe once FreeBSD runs on something like the Pinebook with full graphics support, then it would make more sense to address that.
Yeah, that's it needs more hands in that area, but yeah, it's coming. So then they asked, what does this change, splitting the TrueOS into Project Trident, mean for the Lumina desktop environment?
Yeah, that was my biggest question too.
It's
Project Trident. A long-term, almost nothing. Lumina is still the desktop project for Project Trident and will continue to be developed and enhanced alongside Project Trident, just as it was for TrueOS. Short-term, we will be delaying the release of Lumina 2.0 and will release an updated version from the 1.x branch, 1.5 instead. This is simply due to all the extra overhead to get Project Trident up and running, so the developers are focused on that instead of the new features of Lumina. When things settle down into a rhythm, the development of Lumina will pick back up.
Okay. And they asked, are you planning on including any desktop environments besides Lumina?
While Lumina is included by default, all the other popular desktop environments will be available in the package repo exactly as they have been before. This is definitely one of the advantages of FreeBSD over most Linux distros in that it's not tightly coupled to any one desktop environment. You can just pick from any of the 100 most popular ones and install the package and start using it.
Yep. So anything, something in there for everyone. And then they asked, any plans to include Steam to increase the user base?
Steam is still unavailable natively on FreeBSD, so we don't have any plans to ship it out of the box. In the meantime, we highly recommend installing the Windows version of Steam through the Play on BSD utility, where there are hundreds of games available.
Okay. And what will happen to the App Cafe?
The App Cafe is the name of the graphical interface to the FreeBSD package utility. It's integrated into the sysadm client created by TrueOS. This hasn't changed. sysadm, the graphical client, and by extension App Cafe are still available for any TrueOS-based distribution to use. So they're not actually part of the Project Trident. They are still part of the core TrueOS.
Yeah. And does Project Trident have any corporate sponsors lined up? If not, would you be open to it, or would you prefer that it be community supported?
IX Systems is, of course, the first corporate sponsor of Project Trident, and we are always open to other sponsorships as well. We would prefer small individual contributors from the community, but we understand that large projects need special purpose goals and are much more difficult to achieve without allowing large corporate sponsorship as well. In either case, Project Trident is always looking out for the best interests of the community and will not allow intrusive or harmful code to enter the project, even if a company or individual tries to make that code part of a sponsorship deal.
And then they asked, BSD always seems to be lagging in terms of support for newer devices. Will TrueOS be able to remedy that with a quicker release cycle?
Yes, that's the primary reason why TrueOS shifted to be tracking the FreeBSD current branch back in 2016. This allows for the changes that FreeBSD developers are making, including new hardware support, to be available, days after they finish it, rather than after the next release, which might be, 3 or 6 or 9 months away.
Yeah, that's a long time for a desktop. And then the last question.
My brand new laptop, everything works under FreeBSD. Super happy.
Yep. So the last question they asked is, do you have any idea when Project Trident will have its first release?
Right now, we're targeting late August, so that's coming up real quick. This is because Project Trident is kicking the wheels on the new TrueOS distribution system. We want to ensure everything is working smoothly before we release it, because we want people to be able to jump in right away and start making their own spins as well. Going forward, we plan on having regular package updates every week or two, so that end-user packages will always be fresh, and new releases of Trident itself with the updated base OS every 6 months. This will follow the same TrueOS release cycle with a small delay.
Okay. Yeah, this is a nice interview and updating people on what they've been working on. And I guess we have to drag one of the project members in front of the camera and ask them more specific questions.
We'll see.
Okay, then next up in our show, we have Stop the Evildoers in their Tracks with the pf-badhost. So this is a nice write-up here. For beginners, pf-badhost is a simple, easy-to-use bad host blocker that uses the power of the pf firewall to block many of the internet's biggest irritants. Annoyances such as SSH brute forcers are largely eliminated. Shodan scans and bots looking for web servers to abuse are stopped dead in their tracks. When used to filter outbound traffic, pf-badhost blocks many seedy, spooky malware containing and or compromised web hosts. So the filtering performance is exceptional as bad hosts, the list file is stored in a pf table, and to quote the OpenBSD FAQ page regarding those tables, the lookup times on a table holding 50,000 addresses is only slightly more than, well, one for one holding 50 addresses. So pretty much no big deal. pf-badhost is a simple and powerful tool. The block lists are pulled from quality trusted sources. There is the firehole, emerging threats, and binary defense block lists, and they are used and are quite popular. Regularly updated lists on the internet's most egregious offenders, so that you always have the latest people in your list. And there's the pf-badhost.sh script that can easily be expanded to use additional or alternative block lists, maybe your own, some people that you have not wanting to connect any further, so that you can enhance it this way. And pf-badhost works best when used in conjunction with the unbound ad block for the ultimate bad host tracking. So there's the how-to here. You can follow, and it's quite straightforward. And there's a couple of notes that you should heed. If you're trying to run pf-badhost on a LAN or using NAT, you will want to add a rule to your pfconf appearing before the actual pf-badhost rules, allowing that the traffic to and from your local subnet so that you can still access your actual gateway and DNS servers, because otherwise it's kind of difficult to get out of your network and reaching other servers. And then conversely, adding a line to the pf-badhost script that removes your subnet range from the pf-badhost table should also work. Just make sure you choose a subnet range or, the actual range that you have that is actually in the list, 192.186.0.0/16, 172.16.00/12, and 10.0.0.0/8 are the most common home office subnet ranges. Yeah, don't block yourself. Don't put yourself on your own blacklist. So that way you cannot do much. But yeah, it's a nice tutorial and easy to follow. And that way you have always the latest bad people that you are blocking out of your network.
This week's episode of BSD Now is brought to you by DigitalOcean. If you hurry up and head over to do.co/BSD Now, they will give you a $100 credit to try out the service. With VM starting at just $5 a month, $100 goes a long way.
Oh yeah, you can do a lot of either a lot of small machines or one big machine for a number of hours. And that's pretty cool because you can do a lot of stuff with that machine or that many machines, depending on which you choose.
Yeah. With a $100 credit that lasts 60 days, you could spin up like 2 of these 8 gig 4-core machines and also use one of the $10 machines at the same time. Or, 5 $10 machines for 2 months or whatever it is you want to do.
Yeah.
Or if you already have an account, then use the coupon code FreeBSD Now, all one word, and you'll get a $10 credit that does not expire.
Yeah, because that $100 thing will not last long, so hurry up if you have not used that one. But the $10 credit for the coupon code Alan just mentioned, that will remain. So figure out what kind of stuff you want to run using maybe the one-click applications. Maybe you want to run a little MySQL cluster or a simple WordPress blog to start with, and that is simple to instantiate on your little droplet. These are the virtual machine names, and then you have your machine. You just have to do the configuration part. The installation is already done for you.
Yep. Anyway, you should check it out, and you get lots of bandwidth, which is nice. Even the smallest VM has a gigabit uplink to the internet and includes a terabyte of transfer. And for $15 a month, you can get 3 terabytes of transfer.
Oh yeah. And there's a bunch of things you can automate in DigitalOcean's cloud. You can run scripts using their APIs written in Ruby, Curl, Go, or their own Docker control panel.
Yep. They also have a great command line utility, doctl. I've used it to create, I think it was 50 droplets, run them for a whole weekend, and then delete them all. Very much easier than doing it manually 50 times.
Yeah, you don't want to click that much or enter that many commands. Just this one, and it will instantiate all the machines that you need.
Yeah, although their web interface is nice. If you don't want to use the command line and the API, going into their interface and being like, I need 3 machines, and it will help you auto-generate a naming scheme and everything. It's quite nice.
Yeah, check out the DigitalOcean website, especially their community section, because they have a bunch of tutorials in case you wonder, how do I set up this servers? I always wanted to do that. And there's certainly a tutorial in there that has covered that.
Yeah, I think there's over 100 FreeBSD specific tutorials among the thousands of tutorials there.
Oh yeah, there should be something in there that you either want to try out or run if you like it. Then definitely check out that user-provided tutorial section, because it keeps growing over the years. It's just getting a lot of updates.
Yep, that's do.co/BSD Now.
All right, flashback. Put on your seatbelts for your time machine thing, and we travel back to 1999. To FreeBSDcon in this next section. Fans of Linux's lesser-known sibling gather for the first time. So we thought we put a little history in here because we like that one.
Yeah. So, that means next year will be the 20th anniversary of this.
Oh, yeah.
Seems like we need to have another FreeBSDcon.
Yeah, just for the Memorex.
Yeah. So
what is this?
FreeBSD, a port of the BSD Unix to the Intel platform, has been around for almost as long as Linux has, but without the media hype. Its developer and user community recently got a chance to get together for the first time, and where did they do it? Where BSD, the Berkeley software distribution, was born 25 years ago. On October 17th of 1999 marked the milestone in the history of FreeBSD. The first FreeBSD conference was held in a city where it all began, with over 300 developers, users, and interested parties attending from around the globe.
Oh, wow.
There were easily 50% more people than the conference organizers had expected. This first conference was meant to be a gathering mostly of developers and FreeBSD advocates. The turnout was surprising and gratifyingly large. In fact, the attendance exceeded expectations so much that Kirk McCusick, and to add for a second, had to add a second identical tutorial on the FreeBSD's internals because it was impossible for everyone to fit in the room at once. So he had to teach the tutorial twice during the conference.
Oh, that's a good problem to have.
With half the class each time so that everybody would get to come.
Ooh, yeah. Wow.
But for a first ever conference, I was impressed by how smoothly everything seemed to go. Sessions started on time, and the sessions I attended were well run. Nothing seemed to be too cold, dark, loud, late, or off-center. Of course, the best part about a conference such as this is that one of the opportunities to meet the other people who share a similar interest. Lunches and breaks were a good time to meet people, as was the Tuesday night beer bash. Wednesday night reception was of the type unusual for a technical conference, a 3-hour hornblower dinner cruise across San Francisco Bay. And not only did we enjoy excellent food and company, we all got to go up on deck and watch the lights of San Francisco and Berkeley as they drifted by. Although it's nice when a conference attracts thousands of attendees, there are some things that can only be done with a smaller group like this.
Oh, yeah.
So in short, this was a tiny conference, but it was very well run.
Mm-hmm. And so they talk a little bit about sessions there. So although it was a relatively small conference, the number of and quality of the sessions belied the size. Each of the 3 days of the conference featured a different keynote speaker. In addition to Jordan Hubbard, Jeremy Allison spoke on Samba futures on day 2, and Brian Behlendorf gave a talk on FreeBSD and Apache, a perfect combo, to start off the 3rd day.
I did not know that Brian Behlendorf had a connection to FreeBSD from back then.
See, we should remind him when you see him next time. So
yes,
did you remember?
He's basically the head of the ZFS on Linux project now.
That's a small world, yeah.
Mm-hmm.
But yeah, and the conference sessions themselves were divided into 6 tracks: advocacy, business, development, networking, and security, as well as panels. The panels track featured 3 different panels made up of 3 different slices of the community: the FreeBSD core team, a press panel, and a prominent user panel with representatives from such prominent commercial users as Yahoo and US West.
Which was a big
wow.
MSP.
Yeah. Oh, cool. Back in the day, 1999. Yeah. And it was especially interesting that Apple Computers Talk in the development track, Wilfredo Sanchez, technical lead on open source projects at Apple, no, that's not an oxymoron, spoke about Apple's Darwin project, the company's operating system roadmap, and the role of BSD, and specifically FreeBSD in Apple's plans. Way back when. And Apple and Unix have had a long and uneasy history from the Lisa through the AUX project to today. Personally, the author of this piece here is very optimistic about the chances of the Darwin project to succeed. Well, in retrospect, it did, yeah. Apple's core...
And it didn't at the same time. Nobody uses Darwin.
Yeah. Yeah. So Apple's core operating system kernel team has chosen FreeBSD as its reference platform, and looking forward to what this partnership will bring to both sides. Yeah, I guess it was pretty freshly announced back then, so... Yeah.
Other development track sessions included in-depth tutorials on writing device drivers, basics of the VINUM volume manager, I forgot that was still a thing. Fiber channel development modules and the open repository model, and the FreeBSD documentation project. If you're interested in contributing to the FreeBSD project, the FreeBSD documentation project is a good place to start.
Yeah, see, it hasn't changed much. You just replace VNUM Volume Manager with ZFS and Fiber Channel with, well...
iSCSI.
iSCSI. And you have the modern day FreeBSD or BSD conference.
Advocacy sessions included how one person can make a difference, a timeless topic that would find a home at any technical conference, and starting and managing a user group, the trials and tribulations as well as rewards of that. Both of those is definitely timeless. The business track features speakers from different commercial users, including Cybernet, US West, and Applix. Applix presented its port of the Applix Office software to FreeBSD and explained how Applix has taken the core services of Applixware into the open source realm. Commercial applications and open source were once a rare combination. We can only hope the trend from that state of affairs will continue. And then there's some talk about commercial use of FreeBSD. The use of FreeBSD in embedded applications is increasing as well, and it is increasing at the same rate that hardware power is, which back then was really fast. These days, even inexpensive systems are able to run the BSD kernel. The BSD license and the solid TCP/IP stack prove significant enticements to this market as well. Unlike the GNU public license, the BSD license does not require that vendors make derivative works open source. Companies such as US West and Vario use FreeBSD for a wide variety of different internet services. Yahoo and Hotmail are examples of companies that use FreeBSD extensively for more specific purposes. Yahoo, for example, has many hundreds of FreeBSD boxes, and Hotmail has almost 2,000 FreeBSD machines in its data center in San Francisco. Hotmail is now owned by Microsoft, so the fact that it runs FreeBSD is the secret. Don't tell anyone. When asked to comment on the increasing commercial interest of BSD, Hubbard said that FreeBSD is learning lessons from Red Hat. Walnut Creek and others with business interests in FreeBSD have learned a few things from the Red Hat IPO, and nobody is just sitting around content with business as usual. It's clearly business as unusual in the open source world today. Hubbard had also singled out some of BSD's commercials partners, such as Whistle Communications, for praise in his opening day keynote. Those partners play a key role in moving the project forward, he said, by contributing various enhancements and major new systems, such as NetGraph, as well as contributing paid employee time to be spent on FreeBSD. Even short FreeBSD-related contracts can yield good results. An example can show that the new jail security system introduced in FreeBSD 3 and 4, which was contributed by R&D associates. A number of ISPs are also now donating hardware and bandwidth that allows the project to provide more resource mirrors and experimental development sites.
And then they have a section on see you next year.
Yeah. And speaking of corporate sponsors, thanks go to Walnut Creek for sponsoring the conference and Yahoo for covering all the expenses involved in bringing the entire FreeBSD core team to Berkeley. As a fan of FreeBSD, I'm happy to see that the project has finally produced a conference. It was time. Many of the 16 core team members have been working together on a regular basis for nearly 7 years without actually meeting face to face. It's been an interesting year for open source projects, and I'm looking forward to the next year and the next BSD conference to be even better.
Oh, yes. I think people have carried that torch forward throughout the next years. Mm-hmm. I mean, pretty much all the BSD conferences I've been to were well organized, well run, and had a lot of cool talks and tutorials. Mm-hmm. So in that regard, the tradition went on. If only that. I mean, the code improved also from there, but it's interesting to see the beginnings of the conferences. So, time for the news roundup this week. Coming back from history lane, we landed now in the modern day and age with the problems that we have to deal with. For example,
future.
yeah. It's a little bit darker on this part, at the moment at least. So we have news from OpenBSD. They recommend to disable SMT hyperthreading in all Intel BIOSes because vulnerabilities. Here's posting from OpenBSD Tech from Theo de Rat. 2 recently disclosed hardware bugs affect Intel CPUs, or if only 2. Well, TLBleed and T1TF. The name foreshadow refers to one of 3 aspects of this bug. More aspects are surely on the way. And solving these bugs requires new CPU microcode, a coding workaround, and the disabling of SMT/hyperthreading. So SMT is fundamentally broken because it shares resources between the 2 CPU instances, and those shared resources lack security differentiators. Some of these side channel attacks aren't trivial, but we can expect most of them to eventually work and leak kernel or cross virtual machine memory in common usage circumstances, even such as JavaScript directly in a browser. And there will be more hardware bugs and artifacts disclosed. Due to the way SMT interacts with speculative execution on Intel CPUs, he expects SMT to exacerbate most of the future problems. Yeah, it's going to be getting worse for a while before it gets better. A few months back, he urged people to disable hyperthreading on all Intel CPUs, and he needs to repeat that in all caps. Disable hyperthreading on all your Intel machines in the BIOS. Also, update your BIOS firmware if you can, if there's a firmware available. OpenBSD current and therefore 6.2 will not use hyperthreading if it is enabled and will update the CPU microcode if possible.
That's a 6.4. There's a difference.
Oh, 6. Sorry, yeah, that's 6.4. And then the question is, what about 6.2 and 6.3 of OpenBSD? The situation is very complex, continually evolving, and is taking too much manpower away from other tasks. Furthermore, Intel isn't telling us what is coming next, and they're doing a terrible job by not publicly documenting what operating systems must do to resolve the problems, they write. We're having to do research by reading other operating systems. there is no time left to backport the changes. We will not be issuing a complete set of errata and sys patches against OpenBSD 6.2 and 6.3 because it is turning into a distraction. Rather than working on every required patch for 6.2 and 6.3, we will refocus manpower and make sure 6.4 contains the best solutions possible. So please, he urges, try to take responsibility for your own machines. Disable SMT in the BIOS menu and upgrade your BIOS if you can. And he's going to spend his money at a more trustworthy vendor in the future. He closes the message with. Yeah. It's definitely a problem that we will carry around for a while. At least next year, I guess. Yep. But yeah, it's good to have.
Is getting Morrowind running on OpenBSD in 5 simple steps. So this is a video game, if you're not familiar. So this article contains brief instructions on how to get the apparently greatest Western RPG of all time, Elder Scrolls 3 Morrowind, running on OpenBSD using the OpenMW open source engine recreation of the game. These instructions were tested on a ThinkPad X1 Carbon Gen 3. The information was adapted from a post on the OpenMW forums. So you need to purchase and download a DRM-free version of the game from GOG, Good Old Games. Then you can install the required packages from the ports tree as root. They need OpenMW, which is a recreation of the game engine, and the INO extract, which will extract the game data from the old Win32 executables. Then move the files from the GOG setup directory into its own directory, and then extract the files. Then you can run the OpenMW wizard and follow the straightforward instructions, and note that you have a pre-existing installation, and select that Morrowind app data files directory. And then when you run OpenMW launcher, the game will start.
Ooh, excellent. See, that's dedication from a loyal fan base of a game, that they will make sure that it's still available to play, and they recreate these engines and make it possible to work on modern hardware. That's certainly dedication to a good game.
Yep.
I mean,
for me, the first one I saw do that was Transport Tycoon Deluxe.
Oh, yeah.
Originally, there was basically a binary patch that made the game slightly better, but you could always run into problems if you made a train that was too long or a bunch of other things. So eventually, they just rewrote the entire game from scratch, open source, and you get OpenTTD with just an import of the original old graphics, so it looks the same.
Yeah, for nostalgics. But yeah, and I also saw in a couple of years ago that they were trying to run Final Fantasy VII on a much better rendering engine, and all these things are like, these are not just gamers, these are really serious programmers. I mean, this is engine programming, and this is not something you would do on a weekend. This is serious work. So definitely try this out if you're on OpenBSD, and I guess it's probably possible to also, if the OpenMW engine is available as ports in other operating systems, to run it there as well. That's cool. Also sponsored this week's episode is sponsoring IX Systems. Head over to systems.com and /BSD Now. You will get a nice little guide to and give you an idea of what you should ask storage vendors in if you're looking for a new server or a new storage system, what you should ask them about a certain disruptions that open source is taking. Like, can I get my data back from your proprietary system? And you would find that IX Systems are the people who provide you an open system that will not only save your data in a proper way, but also enables it to get out of there in case you need to switch platforms for whatever reason.
Yep. So if you need more hardware, head over to ixsystems.com, get in touch with them, tell them we sent you, and you'll get a good deal, like I did.
Yeah.
Earlier this week, we finally got the last of our new hardware in and redid our rack at our office here. And I posted some pictures up on Twitter. You can see at the bottom, I have a 6 kilovolt amp battery backup system. And the second thing above that is a battery expansion for it to give me enough runtime. And then you can see a big IX4U system with 24 disks. and a pair of high-end Xeon processors in it. Then above that is another 4U chassis that looks the same, but is actually holds 44 disks. Then above that is another machine that's, again, 24 disks. And then above that is another machine that's 12 disks. And above that, one more that's also 12 disks.
You have some serious blinking lights going on in there. That's certainly interesting to watch.
But you can see on each one, you get this IX Systems logo. And that's how you can tell this one's older. This one's older because it's got the older IX Systems logo on it.
Yeah, you can see the history of how the logo evolved over the years. And
as I started buying bigger and bigger machines.
So all these systems are custom built to your use case?
Yes, I had very specific uses, kind of this, go back to the picture there. This one here, once the screen thinking catches up, come on, there we go. This one here, I went with SATA disks rather than SAS. So I didn't want an expander, a SAS expander, because that way if one SATA disk drives, it can take out the whole branch of the expander, whereas what I did instead is, so in this machine we have 24 5 terabyte disks, but we bought 3 separate LSI HBAs, so every disk is 1-to-1 mapped to the controller, or what we call direct connect, so that if there's a problem with a disk, it only affects that one disk. And so IX helped me build a machine knowing that I was going to use SATA disks instead of SAS disks, whereas this one, the front 24 drives are 6 terabyte SAS drives, and the back, which holds 20 more slots, has 10 12 terabyte drives, and then 10 slots that are empty for me to add more drives in a couple months. So actually, when I bought this, the front was full and the back was empty. And over time, I've added more and more disks. Or like this machine at the bottom here, originally, the front was full of 6 terabyte drives, but we were running out of space. So I pulled out 12, the first 12 drives, and replaced the 6s with 12 terabyte disks, and so on. And so IX knew what my machine was from its serial number and made sure to ship me the new hard drives in the right kind of trays for me to just plug them in and not have to fiddle around with, 150 tiny screws and so on.
Yeah, and that's what IX System provided you with all the pre-packaged stuff. So you just have to put it into the base.
Yep. We're pretty much done with IX now, but I got a couple more pictures of this for people that are interested. People asked about it heating my house. It's actually no, the server room is cooler than most of the rest of my house because I have this Dicon ductless air conditioner. It is literally like exactly a slightly newer model of the one from the Villa Fontaine in Japan.
Oh, yeah. I remember those.
So I have an English remote for it.
Okay, yeah.
It just happened to be the recommended one for what I needed. Also partly because it also has a heat pump, so it can, if someday in the future I'm not running the basement bedroom as a data center, rather than just a big ugly air conditioner on the wall, it also could heat the bedroom in the basement, which is pretty useful if somebody was trying to live in the basement.
Yeah.
But right now it is keeping the basement bedroom at 21°C or 70 Fahrenheit, and keeping everything nice and good. Someone also asked about the power strip. So at the back, we have also Eaton 240 volt power strips. And you can see right now it's doing about 1300 watts. One thing I forgot as part of the switchover from 120 volt to 240 volt was that I would need different power cables to go from the power strip to the machines. And I didn't quite have enough. So not everything's actually plugged in yet. And Amazon should deliver more cables tomorrow.
Ship faster.
I'll provide more stats on my rack and so on once I get everything actually plugged into the UPS. Because I'm also interested in to see what my runtime is going to be with everything hooked up.
Sure.
And so here's more pictures of the power bar. You can see Andrew's tried to label the power cables a little bit so we can know what one's what when we need to undo it. We'll probably do a better job with that once we're finished, but we're just roughing things in. We're just trying to get everything back online after we switched all the power around. So here's the back of the rack. Still not quite finished with all the cabling. It's not as neat as it could be, but it's a lot better than it was at the same time. And as you can see at the bottom here, there's that machine with the 24 drives at the front. And then this is the shelf where you can see you actually get 20 more drives at the back, with just a cutout here for the power supplies and the SAS connectors, and an IPMI so you can control the fans in it and so on. And then another one of these machines, and then 2 more machines. People also asked a bit about noise. Because we keep it so cool in there, and we set the fans in the IPMI system to optimal, which makes them spin up and down based on temperature, it's actually not very loud. Maybe I can do a recording or something from there next week. But it's in a bedroom in the basement. So once we close the door, outside of that door is our office, where the 3 of us sit like 4 days a week and work. And you basically don't hear it, which is fine. And, my bedroom is practically directly above this, and I don't hear it at night either. So it works out pretty good.
That's a big win, yeah.
Fans are high frequency noise. Just a door is enough to deaden a lot of that.
Huh.
And mostly keeping it cool enough means you don't, get too hot.
Yeah, if you need a splash of cold, then just enter the server room and then. Yep. Okay, yeah, trying to get back here.
Yes.
After a little server tour.
If you can stop drooling, now we can talk about the next news story.
Yeah, this is also interesting for the bug hunters out there because it's called My First Clang Bug. And starts with part of the role of being a packager is compiling lots and lots and lots and lots of packages. That means compiling lots of code from interesting places in a variety of styles. So in the author's opinion here, I think we have that already on the show, on this blog. At least the author has written a couple of blog posts here. In their opinion, being a good packager also means providing feedback to upstream when things are bad. That means filing upstream bugs when possible and upstreaming those patches. So one of the exciting moments of packaging is when tools change. So each and every major CMake update is an exercise in recompiling 2,400 or more packages and adjusting bits and pieces. When a software project was last released in 2013, adjusting to it to use modern tools can become quite a chore, like a Squid report generator. CMake is excellent for maintaining backwards compatibility, generally accommodating old software with the new policies. And the most recent 3.12 release candidate had 3 issues filed from the FreeBSD side, all from fallout with older software. So they considered the hours put into a good bug hunting part of being a good citizen of the free software world. Excellent. That's good approach. So the most interesting bug this week, though, came from one line of code somewhere in Cleopatra. Q_unused, and then as a parameter, GPG_agent_data. That's a simple function call. So that one line triggered a really peculiar link error in KDE's FreeBSD CI system. There's a link if you're interested in our show notes, if you want to look at those KDE builds. Telling the compiler something is unused made it fall over. Commenting out that line got rid of the link error, but introduced a warning about an unused function. Well, So working with KDE PIMS Volker Krause, we whittled the problem down to a 6-line example program. 2 lines if you don't care much for coding style. And he's glad that at this point that you could throw it over the hedge to the LLVM team with some explanatory text. Watching the process on their side reminds them ever so strongly about how things work in KDE, or FreeBSD for that matter. Bugzilla, Fabricator, and Git combine to be an effective workflow for developers, perhaps less so for end users. And so today they got a note saying that this issue has been resolved, and a brief time for a bug, live fast, get squashed young. Oh yeah, cool. Yeah, porting work is a lot of, it's unthankful work. I hope people get enough thanks for that work, but just getting stuff done as dependencies and resolving those and making them work, just because something somewhere over here has changed that trickles down to many other software packages, that's a huge deal. And maintaining that is a lot of work, and it's probably not something that many people would like to do. So even more kudos to the people who are doing it.
Yep. So next up, we have news about DragonflyBSD on new Threadripper 2990WX.
And it also says developer shocked at performance.
Yes, well, we'll get to the Dragonfly bits in a sec. Apparently somebody sent us this link to Phoronix. But it said last week Phoronix carried out some tests on BSD versus Linux on a new Threadripper 2990WX. Testing FreeBSD 11, FreeBSD 12, TrueOS, and some Linuxes. They tried Dragonfly, but at the time it wouldn't boot on the AMD high-end desktop processor. But since then, Matt Dillon has got it working. So over to the Dragonfly mailing list, Matt Dillon says, a few minor commits and Dragonfly Master is now able to run on the new Threadripper. The CPU is a real beast, packaging 32 cores and 64 threads. With that, it blows away our dual socket Xeon to the tune of being about 50% faster in concurrent compile tests. And it also blows away the older 4-socket Opteron by about that same margin, making it an impressive CPU. For now, the new beast is going to be used to help us improve I/O performance through the file system, further SMP work, but Dragonfly scales pretty well to 64 threads already, and perhaps some drivers to work to support the 10 gig NIC that's built into the motherboard. Fortunately, the motherboard I have also has 2 1 gig NICs that are already well supported. But looking over at his benchmarks that he was very surprised by, so we are comparing first a 1-socket 32-core 64-thread Threadripper, the 2990WX, which is 4 channels of DDR4 and runs at 3.4 gigahertz. Then a Ryzen 2700X, which is 1 socket but 8 cores, 16 threads, with only 2 channels of DDR4 and runs at 3.9 gigahertz. Their other comparison is an E5 2620, which is 2 sockets of 16 cores or 32 threads, which gives you 12 channels of DDR4 and runs at 2.1 gigahertz, which is significantly less than 3.4, and a 4-socket 48-core, but just 48-thread Opteron 6168, which provides 16 channels of DDR3, but runs at only 1.9 gigahertz. So test 1 is a concurrent compile test, basically compiling the Alt-Q red part of the Dragonfly base, which is a small 16K source file that is part of the kernel source. Each CPU thread runs a script locked to that thread and execute the compile in a loop about 200 times. The aggregate number of compiles is the same on each machine. So 200 times for the Threadripper, 400 times for the Xeon, about 266 times for the Opteron, and so on. So looking at that, the Threadripper 2 running at 2.666 finishes in a minute and 30 seconds, whereas running at 3 gigahertz, it finishes in 1 minute and 26 seconds. The 2700X takes 2 minutes and 49 seconds. The Dual Xeon, 2 minutes and 16 seconds. And the 48-core Opteron ran in about 2 minutes and 18 seconds.
By comparison, yeah.
Yeah, so basically the Opteron and the Xeon both took about 2 minutes and 16 or 17 seconds, whereas the Threadripper managed to get it down to 1 minute and 26 seconds.
Not
Test
bad.
number 2 was running make-J128 for native kernel with no modules. This creates a kernel compile without any modules. There's a single-threaded make depend stage. Then all kernel files are compiled concurrently with no gaps. Then a single-threaded linking stage at the end. So the difference will be the first and last bits will be the same basically across the CPUs. so the difference won't be quite as noticeable, but it'll be there. Basically running that. The Opteron took 2 minutes and 7 seconds. The Dual Xeons, 1 minute and 11 seconds. The Ryzen took 58 seconds. And then the Threadripper, they compared it at 2133, 2166, and 3 gigahertz, where it took 1 minute, 4 seconds, 50 seconds, and then down to 48 seconds at that top speed. Wow. So I'm going to talk a bit about overclocking. He says, I ran the concurrent compile test with the CPU power envelope increased from 250 watts to 500 watts. At stock speeds, the CPU ran at around 3.4 gigahertz on all cores at full load, overclocking it and ran it at 2.9 to 4 gigahertz on all cores at full load. However, the concurrent compile test was only 2 seconds faster, even with all that extra overclocking. This was with the memory running at 2.66 gigahertz. I honestly don't want to run the test again with the memory at 3 gigahertz because I only have a 650 watt power supply.
Yeah, it has to come from somewhere.
What I think is going on here is that the concurrent compile test is limited by memory bandwidth, and overclocking the CPU doesn't help. Otherwise, though, for workloads that have more computation and less memory bandwidth, I would expect significant scaling going from 3.4 to 4 gigahertz, basically another 20% performance. But I won't do that for real because power efficiency goes to hell when you do that.
Yeah.
This is somewhat validated by the tests on the 2700X, where the maximum amount of CPU is available, but with only 2 memory channels. The result of that concurrent compile, test 1, took almost precisely twice the time. So it is clearly possible that the 2990WX to limit out because of memory bandwidth. He also looked at some synthetic tests. One of the fun tests we do with the Beefy machine is a full bulk build of ports, which is currently around 30,500 applications, including all the flavors. This is not a well-controlled test because the port set is getting bigger all the time, but it gives us a very good performance metric for a heavily loaded system during a massive amount of concurrent compilation and file system access. It allows us to test performance, enhancing algorithms in the kernel, and other things. So the Threadripper, with only 64 gigs of RAM and 96 gigs of SSD versus the dual Xeon and the dual Opteron with both 128 gigs of RAM and varying amounts of SSD. Oh, sorry, that's SSD swap. Anyway. So using the synth tool, the workload is a memory heavy and system call heavy, but all extracted working sets for the build are in TempFS, so permanent storage is barely touched and basically not relevant to the test. A full bulk build with a recent version of D ports with flavors takes around 21 hours on the Xeon and only 18 hours on the Opteron. The Threadripper runs the build in 12 hours, which is 75% faster than the 2-socket Xeon and 50% faster than the quad-socket Opteron. Not only that, but since I only have 64 gigs of RAM in the Threadripper, where the other two have 128 gig, I had to balance the workload against paging load, with the results being significantly more CPU idle time on the Threadripper during the test than either of the other systems. This means the Threadripper will be even faster if I can get it some more RAM. And he has some graphs and other stuff and talk about memory timings and power limits and so on.
All things needed to be considered to run that.
With the big warning, you can turn your very expensive CPU into scrap metal if you start messing with the CPU overclocking. Overclocking memory via XMP is relatively safe, but overclocking a Threadripper core CPU frequency can be very dangerous. He's actually got some numbers looking at running the memory at everywhere from 2.1 to 3 gigahertz, looking at the change in the compile test and the change in power usage. So with the CPU staying at the same 3.3 to 3.4 gigahertz range, at 2.1 gigahertz on the memory, using 229 watts, but taking a minute and 57 seconds to do the test, and with the memory pushed up to 3 gigahertz, you're using 300 watts, but only taking 1 minute and 27 seconds to do the test. And then the difference in idle power is about 20 watts.
Okay. Well, that's certainly a machine that will come in handy for building ports and systems, recompiling and recompiling new changes and tests. Yeah, cool thing.
Yep. And it also talks a bit about being able to set the power throttling limit and basically make the machine use less power, which makes it a little bit slower. But with the 100 watt PPT limit set, his concurrent compile test is only losing 3 seconds, but he drops the power draw from 275 watts to 158 watts.
Mm-hmm. Cool. Definitely worth having.
Yeah, it says it seems to be at least 50% faster than the dual socket Xeon he was testing against. It didn't say which generation that was, the 2620 there. 5620. But he says the primary limitation might be the fact that it only has 4 channels of RAM.
But yeah, still, even in the basic configuration, it's mind-blowing, quick, fast, and yeah.
Yeah, well, it'll be interesting is now we need Kevin to benchmark his Raptor Power 9 system.
Against it. Yeah,
I think it's only got
same workload,
18 or 22 cores, but it has 4-way hyperthreading, or SMT or whatever. So instead of 2 threads on each core, you can have up to 4. Although I think it's configurable between 1 and 4, which is also interesting.
So, time for Beastie Bits this week, starting with X11 on really small devices by Janne Johansson and over at undeadly.org. Writing, Patrick Wilt, which is Patrick at OpenBSD.org, has been experimenting with small I2C and SPI connected devices, or displays in particular, and with this commit linked in the message, it was enabled for ARMv7 and ARM64 platforms as SSDFB in Concurrent. So one might think using a SPI connected 128 by 64 pixel display would only be good for displaying small pieces of information like load or temperature or whatever some sensor would tell you. But this grew into a complete frame buffer, which in turn allows you to run X11 against it. And that is what it ended up being, a complete display. So he asked nicely, and he agreed to make a short clip of what it looks like when used together with X11 and FWVM. So you see how the experience might be. Downloading, there's a little clip here linked. And oh wow, the driver needed a slight edit to support I2C on NanoPi Neo 2, as seen here. Also another link. But other than that, it's fully functional. There's a little login screen. Perfect. Yeah, see, you never know what this might end up running on because it runs OpenBSD, I guess. So very cool. And yeah, for people who want to have a small display device and don't know what to do with it, then that's also possible to run X11 on.
Mm-hmm.
And then
next up, Mandoc 1.14.4 has been released. So Ingo Swarzi, as when wearing his OpenBSD only hat, wrote in to let us know about the new release. So after a full year of tranquil development, just released Mandoc 1.14.4. This is a regular maintenance release as there are no major structural changes. I expect it to be very stable, so all downstream systems are encouraged to upgrade from any earlier version. There are 2 important new features. In the output ASCII mode, rendering of mathematical symbols in Greek letters is decisively improved. Interesting, as originally the main reason Christophs worked on Mandoc was for mathematical formulas, not for man pages. Mm-hmm. When no unambiguous rendering as a single ASCII character is possible, symbols are now rendered as strings describing the meaning of the symbol. There's an example of the 1gamma3 man page. You can see that the gamma symbol becomes the word gamma in square brackets there, so that it's more readable. Traditionally, ASCII rendering, most unsuccessfully, attempted to imitate the graphical shape of a symbol, which caused generally unintelligible results. An equivalent change was also performed in Graph-Current. It already patched into the OpenBSD Graph port and will be contained in the upcoming Graph 1.22.4 release.
Cool.
In the mandoc HTML and CSS output, and hence the man.cgi presentation on the web, is now significantly better in many respects. In particular, the first steps were taken towards better usability on small screens and mobile devices using a responsive design. There are no more style equal attributes containing fixed dimensions, but all indentation and distances are controlled by CSS, and a default style sheet uses the @media directive for adapting to the available space. In several cases, the choice of HTML elements was improved, several HTML syntax violations were also fixed, and overall the quality of the default CSS style sheet was improved in many respects. Almost all of these improvements were only possible due to the sustained and detailed feedback from John Gardner, and a link to his GitHub, who taught me a lot about HTML and CSS. So thank you for that invaluable help.
Oh, yeah. Cool. So more mandoc coming our way. And next up, there's the Pfsense book now available for everyone. So this is over at netgate.com. And
the Pfsense book, I think previously was only available to those who had a gold subscription, but now it's available to anyone. So the Pfsense book is now freely available to everyone. As promised in a previous blog post, all the services provided with a Pfsense Gold membership will be made available to everyone by the release of Pfsense 2.4.4. We already made the monthly Pfsense Hangout videos available on YouTube, and we've announced that the automatic config backup tool will be a bundled feature in 2.4.4. In addition to the HTML version of the book, the PDF and EPUB versions are now available and can be downloaded from the table of contents of the book, and a Mobi version is being discontinued.
Cool. Nice one.
So they say, once again, we'd like to thank our Pfsense Gold subscribers for the continued support for the development of the project and the documentation. We'd also like to thank the Pfsense community at large for their steadfast loyalty to the project. We're thrilled to be able to offer the best open source firewall with the best freely available documentation to everyone.
Great. Speaking of documentation, someone else has been keeping up writing. No one else than Michael W. Lucas, and we have a blog post of his titled "Burn It Down, Burn It All Down." So that goes. I burned yesterday and redesigned my websites. What was www.michaelwlucas.com, blathermichaelwlucas.com, www.michaelwarrenlucas.com, and mwl.io have been consolidated in a single site, mwl.io, which you are looking at right now. Fiction, nonfiction, FAQ, and blog all coexisting as one happy family. Happy families are the ones most likely to stab each other in their sleep. But anyway, I have a whole slew of redirects on the old sites, so my incoming links should work. My tiny RSS reader even caught my test post, so I'm pretty sure blog subscribers will continue to get my posts. Spending a couple of days working on this mess wasn't fun, but maintaining 4 sites, the correlated interdependencies, and all the trivial little differences was eating up too much time. So I'll make back this time in a year, and it also gave him the chance to fine-tune his web server's TLS configuration, as 2012's iffy algorithms are downright dubious today. And he closes with, also, I'd like to thank Let's Encrypt for making TLS everywhere a reality. With this integration, would never have happened without an infinite supply of website certificates, and if you're not using them, you should. Yeah, very nice. Nice facelift for the websites. Next is, in our BSD Bits items, configuring OpenBSD system and user config files for a more pleasant laptop. So that's for the laptop people out there who want to have a nice config here. That's a little listing.
Basically some files you can download and put on your machine, and it sets up, MUT and MB-Sync and so on, SSH agent, a lean vimrc designed for C programming, mounting USB keys and FSTab and all that kind of thing.
Oh yeah, and I guess some of these things can also be adapted to the other BSDs. There's nothing to OpenBSD specific to it.
Exactly.
And
vimrc is OS agnostic. Just a reminder about a recent security vulnerability. There's a resource exhaustion in TCP reassembly on FreeBSD. So basically, there's a small revision to that existing patch as well. But basically, one of the data structures that holds TCP segments uses an inefficient algorithm to reassemble the data. This causes the CPU time spent on segment processing to grow linearly with the number of segments in the reassembly queue. So when you're receiving segments over TCP, there's, I think, two separate fixes for this, but there was one where getting the segments out of order. So if you get like segment 1, then segment 10, then 2, and 7, and then 3, and so on, you could make it so that it uses a linked list to walk through them, and you can make the list really, really long so that every time you add one, the kernel is going to walk through that whole list of like 1,000 chunks, and make it just keep doing that and using up all the CPU. And then there was another version where you could do the same thing, but with fragments. So both of these basically, because there was no limit on how many items you could have in the list, walking through that list every time you updated it used up a lot of CPU, and if done many times concurrently, could use up all the CPU on a machine.
Oh, yeah.
An attacker who has the ability to send TCP traffic to a victim system can degrade the victim system's network performance and or consume excessive amounts of CPU by exploiting the inefficiency of the TCP reassembly handling with relatively small bandwidth cost. So you could do a denial of service without needing a lot of bandwidth that would just use up all the CPU on the target machine. So as a workaround, system administrators can configure their systems to only accept TCP connections from trusted end stations, if that's possible to do. For systems which must accept TCP connections from untrusted end systems, the workaround is to limit the size of each reassembly queue. The capability to do so is added by the patches noted in the solution section. So they added a new sysctl that allows you to limit how many, the maximum size of the reassembly queue, net.inet.tcp.reass.maxqlen. And the default value is 100.
Okay, good to know. Another cool thing to know is that OpenBSD Foundation got its first 2018 Iridium donation. So that's over at discoverbsd.com. The OpenBSD Foundation is excited to announce that it has received the first 2018 Iridium level donation. This year, the first 100,000K plus donation came from Handshake, which is handshake.org. And we thank Handshake for its very generous support. This donation will no doubt fund many exciting projects in the coming years. Oh yeah, congratulations. Definitely having continued donations going, and especially in this amount, is a good thing to sustain development and supplying OpenBSD with enough development capacity and the monetary space here.
Yeah,
cool.
Getting the developers to the hackathons and making sure they have the hardware they need to work on stuff and so on.
Yep, they will definitely put it to good use. In
FreeBSD 12, a new commit just went in recently that I think will help address issues one or two people had written into the show about. So this commit imported from ZFS on Linux limits the amount of dnode metadata stored in the ARC. So metadata-intensive workloads can cause the ARC to become permanently filled with dnode objects as they're pinned by the VFS layer. If you remember before, somebody was having the problem where they limited the ARC to an amount of memory, but it was going past that. And it turned out if they lowered the maximum number of vnodes they could have, it went back to normal. That's this problem, basically. Subsequent data-intensive workloads may only benefit from about 25% of the potential ARC size, right? That's your ARC max minus the limit that's supposed to be on metadata only. So by default, normally metadata doesn't take up all of the ARC. it specifically limits metadata. I think the default is 25% of the total size of the arc, so that you leave lots for data. But this problem could lead to that not being the case.
Yeah.
In order to help track metadata usage more precisely, the old other, so when you run top on FreeBSD and it shows the arc in the total frequently used, recently used, buffers, anonymous, etc., there used to be one at the end called other, and that included the dnode stuff and a bunch of other stuff. That one has now been broken out into 3 separate stats. The size of the dbuff cache, which is used for, if you're using compressed arc, it stores the cache of uncompressed buffers that you used recently. The dnode size, which is the one for having lots of files open. And then finally the bonus size, which is the bonus buffers. So now all 3 of those will be separate and you'll be able to tell which one's causing a problem. The new ZFS arc dnode limit tunable is also created and defaults to 10% of the ZFS arc meta limit. So if your arc is 100% or 100 gigs, then your arc meta limit is 25% of that. So 25 gigs, and then only 10% of that can be used for dnodes. So only 2.5 gigs of it could be used for the dnodes. But it's a sysctl, so you can adjust it. And it defines the maximum number of bytes which are desirable to be consumed by dnodes. Attempts to evict non-metadata will trigger an async prune task if the space used by dnodes has exceeded this limit. So next time your arc needs to shrink because it's using too much memory, it will, in the background, try to get rid of some of the dnodes as well. There's also a new ZFS arc dnode reduce percent tunable. Specifies the amount which the excess dnode space is attempted to be pruned as a percentage of the amount by which ZFS arc dnode limit is being exceeded. By default, it tries to unpin 10% of the dnodes. So basically, it will try to free 1% of the arc at a time, right? 10% of 10%. So the problem of dnode metadata pinning can be observed by doing the following. Set your arc max to 4 gigabytes. Create a large number of small files until your arc meta used exceeds the arc meta limit. And then arc prune will start increasing as it tries to free more memory. But if you then create a big 3 gigabyte file and read it repeatedly, instead of pushing that metadata out to cache that 3 gigabyte file, as it should do, the metadata was sticking around because the vnodes were still active. So with this modification, space for the 3 gigabyte file is gradually made available by subsequent demand on the arc, which is causing the arc dnode limit to keep shrinking those dnodes down to make more room available for actual data. So doing a find across a large set of files and so on should no longer chew up all the memory in ZFS and not leave any for you to do other stuff with.
Okay, very nice. Good to have. And remember the beginning of the show where we talked about Project Trident? Well, they tweeted recently in their own Twitter channel, or their own Twitter account actually, that they have a beta release by the end of next week in line. So people should get notified by, either us or from that subscription to that channel that there will be an ISO download for Trident soon.
So Ken said yesterday morning, as I was recording, so it was on the morning of the 28th, I'll be starting the 3 to 4 day build process for the final ISO soon, but if something fails over the weekend, I'll have to start another build, and then it might be not finished until Thursday and so on. The replacement hard drive for the build server still has not arrived yet, so our longer builds have a poor track record at this point. So he's hoping to do fresh soon.
Okay, just a little bit more patience, and then they have an ISO for you to try out.
Yeah.
And we have reminders about upcoming BSD user groups. The first one is in Stockholm on September 5th. And here's the meetup link provided in our show notes. And BSD PL user group on September 13th. And you also can get the link to that one. And if you're in the area, drop by, say hi, and talk to fellow BSD folks.
Yep.
So,
and then there's also the BSD Polish user group, which will be on September 13th at the Wheel offices. And will include Conrad giving a recap of his visit to Cambridge for BSD Cam, Adam Wolk talking about his OpenBSD daily code reading thing that he's been doing, and then lastly, Patrick will be talking about why is ARM a tier 2 platform.
Oh yeah, so there's something for beginners, for more advanced people, and some intermediates, I guess.
Yeah, well, I think they try to have a beginner, advanced, and a not directly BSD.
Yeah, something else track. Yeah, very cool.
Yeah.
So before we get into the feedback and questions this week, we should mention the sponsor for that one, which has been and probably also will be tarsnap.com, your online backups for truly paranoid people. Remember that backup you should have taken? You didn't do it yet? Well, then why don't you use a proper way of doing it using Tarsnap? So Tarsnap will allow you to check out how much data you actually want to back up. Then looking for unique blocks in there, so finding which of them are duplicates in a certain algorithmic way, and that will then deduplicate it, compress it, and then on your local machine still encrypt it, and then once that is done, the encrypted part will go into Amazon's AWS cloud, so no one else can read it because you're the only person holding the backup key. And that way you can also do restores, and you actually pay just a meager 25 cents per gigabyte month, so just to store it, and bandwidth costs are similar. So you can also, they have a little FAQ on their website in the documentation section. You can do a dry run and see how much would it cost for that specific folder or directory, and then you can gauge better how much it would cost you, and then sign up to Tarsnap, get an account there, and start doing backups regularly. There are clients available for the major Linux distributions, the BSDs, macOS, and Windows subsystem for Linux. So no excuse to not back up because you not have that one operating system. They're pretty much everywhere. So use Tarsnap backup in a secure way, but also in a way that no one else can read your backups.
Yes, it'll be secure and verified, and unlike any other backup provider, it's the one where you can check and make sure it's secure. So, question time.
Yep. Let me start the first one. Now that we got actual feedback, our call last week for more feedback didn't fall on deaf ears, so thanks for those. First one is Malcolm, having different routes per interface. So that goes. Hello, I'm going to try to figure out this one by myself, but you've been asking for emails on the show, so I've been lazy and helping the show. Win-win. Okay. I have a FreeBSD machine that has two interfaces, RE0 and WLAN 0. So the WLAN 0 is a Wi-Fi dongle, if that matters. RE0 connects to the internet. I use WLAN 0 as the access point and gateway to the internet. I then run a VPN through a server in another country. With that, I have a Wi-Fi access point that lets me browse from another part of the world, and all I have to do is connect to it with my devices. I'm using OpenVPN for the VPN. So my pf config looks like this. This is pretty much 3 NUT rules and one to keep the state. And the question is, while I want all traffic coming in from WLAN 0 to be routed through the WPN or the VPN, I want all traffic originating on the machine to not be. This machine does some big downloads for backups, and the VPN is lower, and I have to pay for bandwidth. Well, is it possible to set this up so my access point traffic goes through the VPN, but traffic from the box itself doesn't?
Routing tables aren't really per interface, but I guess they can be. So on FreeBSD, you can have multiple routing tables using a system called FIBS, or Forward Information Bases. So you basically set the number of FIBS you want in loader.conf and reboot, and you will then have that many routing tables, and you could set the WLAN interface to use a different routing table than the default one used by the system. I think you can also apply the FIB2 packets in the firewall in IPFW. I'm not 100% sure if you could do it in PF, but possibly. In which case, you could basically just say, as you're doing your NAT on ton 0 from WLAN 0, you can just apply the fibs so that it forwards out the right interface.
Yeah, this should be straightforward, not too difficult to implement.
Even PFU can set the destination.
Yeah, like pass out on...
Right, but yeah, there's might be something special you could do at the end of that the last NAT rule there to force the packets to go to a different destination as well.
Yeah, so not say to any, but to...
Well, no, if you change that, that's the matching part of the rule, right? That controls what packets match that rule. But I think it's...
you can say which interface.
When you specify where you're going to NAT them out of, I think you can set the destination in there as well.
Yeah.
I'm not that familiar with PF. I mostly use IPFW.
Yeah, but it should be flexible enough to do that. Maybe not in FreeBSD is that current version, but I think there are ways to do that.
I think you can do it with fibs and putting in the whole WLAN interface in the fib, but I've not used fibs in that way. I've only used fibs to have different routing tables for jails.
Because that's a typical use case. But yeah, it should work. Okay, I hope that answers your question. And next up is Boston with ZFS and integrity of data. So if that's not a ZFS question, then I don't know. That goes like this. Hi to all of BSD Now makers. I'm a listener from the first episode of BSD Now. I have written in some time ago and hope I haven't burned all the bonuses to ask questions. I've had a conversation about how and where ZFS takes care of the data. We haven't agreed on some areas, so I came to the Grandmaster to help us clarify the topic. The areas in questions are quite similar, but still important to distinguish them. So, so the first one goes like this. ZFS takes care of integrity of the data inside one pool. ZFS doesn't seek help from other pools. If you have the same file in pool A and B, ZFS checks if the blocks of data are correct in each pool separately. If in pool A some blocks of a file get corrupted, ZFS will try to copy data from another VDEV in pool A if one is available. It will not try to copy data from pool B. Even pool B is exact if that is an exact copy of pool A.
Mostly correct. So yes, each pool is completely separate, and ZFS has no way of knowing that those two files are the same anyway. The one caveat there is ZFS will try to copy data from another VDEV? No. In general, each VDEV is responsible for the integrity of the block stored on it. Okay, so the first part is ZFS doesn't care about files at the redundancy level. It just has blocks. The files are up at the top in the ZFS POSIX layer that makes it so you can use it as a file system. But down in the guts of ZFS where you're dealing with redundancy, it only cares about individual blocks. So, one chunk of your file could be lost, but it's less likely that you lose the entire file in a case like that. But anyway, each VDEV is responsible for the integrity of the blocks written to it. And blocks are not spread across multiple VDEVs unless you have copies equal 2 or something like that. So the RAID Z and mirrors are individual VDEVs. So if you have a RAID Z2, then the data is on the other disk in the same VDEV. None of that data actually exists on any of the other VDEVs, and it's not going to be able to go to another VDEV to get it. And this is why you can't import a pool if a whole VDEV is missing, except for maybe read-only. But yes, in the end, ZFS treats each pool completely separately so that something going wrong on one can't affect the other, even though things don't go wrong in ZFS.
Yeah, but it's good to know. So second, errors are not corrected. ZFS can't correct data. It can only detect the corrupted data, and if possible, it can copy data from other VDEVs. So data corruption is not corrected. The data corruption gets replaced from correct copy of data from the same pool. Oh, that needs some explanation.
Again, similar, but again, not a separate VDEV. So when an error is detected, it is corrected by regenerating the data. So if it's a mirror, then yes, that's just copying the data from the other side of the mirror and overwriting the bad copy with a good copy. In a RAID Z, it's slightly more complicated because you don't have another copy of the data. What you have is the parity data. So by using the remaining bits and some brute force math, you can figure out what the missing bit was. In ZFS, this is literally trying, if you have a 5-disk RAID Z1 and one of the blocks is missing, it doesn't know, one of the blocks is bad. It doesn't know which one is bad, right? Because the checksum it has is across the whole file, not just the one block. So if one block goes bad on your 5-wide stripe, it'll just try every possible combination and checksum each one until it gets the one that has the right checksum.
Okay.
And then correct it.
Fine.
So, it'll try A, B, C, D, and A, C, D, E, and A, B, D, E, and etc. Every combination until it finds the one that works. That's why when you get up to RAID Z3 and make them very wide, that gets to be a lot of combinations it's got to try.
Yeah, the more disks, the more combinations. Yeah.
And it's one of the problems of the RAID Z expansion stuff, because some data that was written before will be spread across 8 disks, but the data that was written after will be spread across 9 disks. So now you have to draw every combination for 8 and every combination for 9.
Yeah, plus 1. Yeah.
Yeah.
It's complicated, yeah.
And so on. But yes, so ZFS will, technically it can correct the data by reassembling it with the parity, and then it rewrites it. But again, doesn't go to other VDEVs, because other VDEVs don't know anything about that block in the default configuration. If you have copies equals 2 or 3, it's possible that a block is written to 2 different VDEVs. But in your standard case, it's all done inside the individual VDEV. And that's why, you have a mirror or a RAID Z where it has many disks, so that you can lose one of them and still be okay.
Yep. Okay, so the third question is, assuming data gets corrupted during wire transfer, ZFS replication, aka ZFS send, it will be copied to the new pool corrupted. If the pool...
in older ZFS, the way it worked is there was one checksum at the very end for the whole send stream, and if it was wrong, it would throw everything away. And you have to start over. Actually use the data that was replicated. In newer ZFS, as part of support for resuming a replication stream, we checksum the stream on a regular interval. It might actually be every object, I forget. But as we send the data, we also send a checksum. And the receiver checks that, and as soon as it finds one that doesn't match, it stops the replication, and you then would resume it starting at the last one that was right, and re-replicate it. So ZFS replication already protects you from wire level corruption.
Yep. Using the proper receive, I think -S is the one that creates the resume token.
The resumable, it basically means save the partial replication stream instead of throwing it away.
Yeah.
So ZFS replication could not write corrupted data like that to your pool. Or it might write the data there, but it'll be cleaned up.
The checksum will find it out.
Detects that the checksum is wrong.
Yeah.
Now, we can still talk about the second half of your question, though.
Yeah. So if the new pool, he writes, is a mirror, it will be copied to both disks. ZFS detects corrupted data and lets you know, but it cannot correct the data if data was corrupted during the wire transfer and copied to both disks.
So if you change that question slightly, or first thing, mirrors can be more than 2 disks deep. You can have 2 or 3 or 4 or 5 disk mirrors, but anyway.
Sure.
If, say, somehow both sides of a mirror were to get corrupted because of a bad storage controller, or I've actually had disks where like 8 disks out of a batch of 40 all had bad sector in the same spot.
Oh.
Yes, in that case where both copies are, or all copies of the data are bad, ZFS will detect this and just tell you, hey, this block out of that file is gone, and if you try to read it, it'll return an error instead of giving you the bad data. One of the important things that ZFS does is guarantee it will give you the right data or no data. Whereas other file systems, because they don't know the checksum of the data, they give you back whatever they got from the disk, which might be gibberish.
And then applications crash.
As we know about applications, if you feed them gibberish, sometimes they don't do what you want them to do.
Yeah, they don't check that. They just use it and make things even worse.
So while ZFS replication isn't going to be able to cause this corruption, if this corruption does happen, yes, ZFS will detect it, but not have a way to solve it. So when you do zpool status, it will say, hey, this file or these 3 files or whatever got corrupted. You should restore those files from backup and the rest of your pool is fine.
Okay, so 4th question. There's no ZFS checksumming or other ZFS integrity verification in transit.
So as long as you have the new enough ZFS that it supports resuming replication, it does have checksum on each chunk as it's replicated. If you have older ZFS, the checksum is only done at the very end, which can be really annoying when you send, a terabyte of data over the internet, and then the last one, it says, 8 hours ago there was a checksum error, and you just wasted the last 8 hours sending me data that I'm going to throw away. or worse, it throws away the entire thing, the whole terabyte.
No, and you're like, not again.
Oh, damn it. So yes, there's checksumming in old ZFS, there's checksumming on the whole replication screen. On newer ZFS, it's inline on each object as it goes through. So either way, yes, you are protected in transit.
Yeah. And so during ZFS replication, TCP takes care of the integrity of data in transit. The data from pool A arrives unmodified to pool B, and ZFS doesn't check integrity of data in transit. But I guess we answered this.
Yes, ZFS does, because it doesn't know if you're using TCP or what. Right? You can be using a pipe. You can be, you can do ZFS send it to a file, write that to a tape, put it on a shelf, wait 20 years, read it back off the tape. There's a bit of dust, and you get some, and yeah.
Yeah, so ZFS isn't it's pretty much transport agnostic what it's using. During replication, ZFS copies blocks of data. It doesn't copy files. If some data gets corrupted in a pool, ZFS doesn't know which file that is. It just knows that some data is corrupted. Or does it know which file is corrupted? Yes, it does.
Yes, it does know what file is corrupted. So if you do zpool status -v when there's corruption, it'll actually give you the path to the file, if it can. If you see the article we talked about, I think it was 2 weeks ago from the University of Toronto on how ZFS is able to quickly look up what the file name of something is. So in ZFS, every block is stored as an object. Or sorry, every file? Yeah, a file is an object and then it has extra stuff. Anyway, the file has an object ID, which is kind of like its inode number. And as part of the metadata, it also knows the parent, the directory that it belongs in. So if you walk up one level to that directory, you know the object ID and you're at the parent now, you look it up in the key value pair and it'll tell you the file name. And so ZFS can map backwards to the file name. Now, sometimes you'll see ones that are just hex. That's just the object number. It's because it's metadata that doesn't have a file name. Or a file that's been deleted and so therefore doesn't have a file name anymore.
Yep. But it's easier to pinpoint which files need to be copied again.
The nice thing with zpool status -v is if there is corruption, it will tell you the individual file names you need to restore, which makes your life that much easier. And if it just says, 0x7b4 whatever, then it's a file you either deleted or it wasn't a file or whatever, and you can probably just go about your day.
And last question, does ZFS check data integrity during replication? When does it do it? A, ZFS checks for integrity of the data in pool B during replication, or B, immediately after the replication finishes, or C, does not check for integrity of the data, you have to run scrub.
So, older ZFS, it would check at the very end before it would actually let you use the file system. So it's receiving it all and writing it to the pool, and at the very end, if the checksum doesn't match, it would erase it all. Before it would let you actually mount the data set or whatever. In newer ZFS, it checks each object as it receives it, and it will cut the transfer off as soon as it finds one that doesn't match. This way, you can then do a resume from the last file that did finish and keep going. Instead of replicating all the way to end and then finding out the third file was wrong, so I'm going to throw away all your work. But, the resume feature has been around since 2005, I think. So pretty much everywhere should have that by now. And you should be safe.
Yep. Cool.
Yeah, ZFS puts a lot more effort into protecting your files than most people even realize.
Yeah, and people can rest easy to not know these internals, but still make sure that the files they put on the ZFS pool or on the ZFS datasets are secured. Okay, that was Bastian's question. Thanks for those. Next up is Michael with a suggestion for monitoring. From us, of course. Alan and Benedict, he writes, first, thank you for making and maintaining the podcast. It really helps me feel connected to the BSD community. So on to the question. Do you or anyone you know have a suggestion as far as a clean monitoring dashboard solution for keeping tabs on, visualizing system statistics and performance data? I'm aware of RRD Tool, Collectd, Graphite Prometheus, and Grafana, but wanted to reach out before jumping headfirst into configuring and testing such a stack from scratch. I'm running into the classic, someone has probably already done this better than I have ever could, feeling. If the tools I mentioned are indeed the way to go, I'll get started on them and try to make a write-up when I'm done.
Yeah, our setup is kind of old-fashioned, but it's basically Nagios and Nagios Graph, which is using RRD tool. The graphs are not as pretty as something you would get with something newer, but we kind of, Nagios is what we already had, so we just extended it and extended it and extended it with all of our data.
Yeah, as networks grow or the things that monitor that need to monitor grow also, the monitoring system it takes on more tasks, and then it's easier or more difficult to swap them out. So I use a combination of Moonin, which is going out. I will not use this any further because it doesn't scale up with the number of machines, but it basically creates these RRD graphs, which are nice to see. I use Telegraph and putting that into Grafana and making nice dashboards, because a couple of dashboards available for BSD systems even on the Grafana dashboards download page, so you can just grab them with their ID. And the other thing that I'm looking at is collecting not just the graphs and the metrics, but also the log files. That's a different part of monitoring. You also need to know what's happening in your log files. And for that, I'm still experimenting a little bit with Greylog and the Elk stack to just figuring out what works best for me. But this is also another case where you need to be aware of what your systems are doing. There's not only the metrics you're collecting, but also what's in the log files, and what errors are there, how many user attempts have there been logging in on SSH and things like that. Okay, I hope that gives you a couple of pointers.
I know Collectd is pretty good, and I've heard good things about Graphite and Grafana and so on. It really depends what kind of a dashboard you want. In ours, it's less that we want a dashboard and more that we need to be able to deep dive into the history of a machine going back a month or two. Or,
I mean, you can spend hours customizing these dashboards to your liking, and just one more graph and one more metric. But yeah, it's a very deep rabbit hole to get in. But as long as you get the most important data, CPU, memory, disk space, and that should get you started at least.
None of those are on my top 3 for metrics on my servers.
Okay, yeah, well.
Our CPUs are never busy, so we don't worry too much about the CPU. It's a graph somewhere, but it's not something we ever worry about.
Yeah, your use case is different than mine. I just have to catch the people running Bitcoin miners and things like that. So that's a good question. If someone else has something else, then write it into our feedback section, feedback@bsdnow.tv, and we'll add it to a future episode. And last question for this week is from Barry, starting like this. First, I really enjoy your show. That's glad to hear. I have used FreeBSD since 2.1.5. Oh, wow, way before my time. That I got at Christmas 1996. Oh, wow. On a Walnut Creek CD-ROM I bought at a computer store when I lived in Houston. I mainly worked in the Linux world as a DevOps engineer. Well, I guess you didn't call it DevOps back then, but yeah, I know where we're getting at. Only have had one job where I used FreeBSD in production. First, what software do you use for recording your podcasts? I have an interest in maybe doing a podcast of a couple of our local meetups, so interested in any pointers or suggestions of software to try.
So we're still using a commercial software called Wirecast, but I would recommend OBS, the Open Broadcaster Studio. It's what we use at my work every day to do. It's almost as good as this $1,000 software, but it's open source. It does the compositing. You can layer multiple things. You can do the scene switching. It does all that, and it actually supports more stuff. And the main reason we're still using Wirecast is I haven't had time to change anything. But I'm definitely not going to be paying to upgrade Wirecast ever again. So yes, OBS is probably the best, and it even runs under FreeBSD.
See?
We use it at work all the time to send test streams and so on.
Excellent, yeah. Yeah, a lot of YouTube streamers are using that as well for post-production.
Yeah, and then like for this show, literally, it's the red bits kind of around it. There's a transparent PNG file. That's one layer. And then my camera and Benedict's camera are two more layers. And then a web browser is the big middle of the screen there. And that's all there is to it.
You destroyed the whole magic, yeah.
It's not like on the previous podcast I did, TechSnap, the other host was in a studio with a fancy camera that shot green lasers at him, and it did green screen stuff. We don't need any of that, although that is possible to do in OBS as well.
Okay.
So I would recommend OBS.
Okay. So second, since a lot of things have changed lately in the world of video cards and support, maybe a good set of shortcut tutorials or short tutorials would be one to do on setting up Xorg with the latest model of NVIDIA, a late model AMD, and a late model Intel chipset.
For NVIDIA, package install NVIDIA-driver. For Intel, package install DRM-next-kmod or DRM-stable-kmod, depending on whatever you want. And there's a couple instructions, and those both just work. The AMD, I'm not sure on. I know there are some AMDs that are supported by that DRM next driver, and there are some that are not. I don't know what's what.
Yeah, there should be plenty of tutorials out there, or check the FreeBSD forums that should have a couple of tutorials or instructions, but it's not too difficult. Third, you should do another t-shirt with BSD Now on it, or just offer BSD t-shirts for sale to help cover the cost of your podcasts. Besides, all of us need more geeky, nerdy shirts in our closet, or in our overflow area for shirts that no longer fit in our closet.
I'm wearing the last kind of lame one we'd actually did. I suppose the podcast is doing fine. It's not, it doesn't really cost us much to do the podcast. It's just Benedict and I's time is really the main cost of everything.
Yeah. Fan service.
But yes, I suppose we could come. I'd really like to do something interesting and cool. I just haven't managed to think of anything.
Mm-hmm. Yeah, well,
in general, I have enough T-shirts now.
From the BSD conference.
I would like to do something else, but I don't know what. So if you have any ideas, let me know.
Yeah, we'll try to come up with something. Okay, number 4. I think a tutorial on how to set up the firewall to allow a person to run a mail server and a web server on a FreeBSD box in the proper way to secure it. Oh, we had that a couple of times on the recent episodes.
Yeah, firewall's pretty straightforward. You need ports 80 and 443 for the web server, and was it like 25 and selection of other ports for the mail server, like 465, 587, whatever, and then your IMAP and IMAP over TLS or whatever. Not much special there.
And number 5 is a tutorial on how to choose a wireless chip or card and Bluetooth chip card or card that has robust support in BSD, yet still can do some of the latest speeds. I know this is a moving target, but there is so much variation of information on the subject out there that doesn't seem consistent.
Yeah, I would recommend Intel wireless, the 6502, I think, or 6205, and basically an Intel 6000, 7000, or 8000 series Wi-Fi should work under the IWN or IWM drivers on all of the BSDs.
Mm-hmm. Yep. Otherwise, then check forums. People are reporting, or the laptop pages on the FreeBSD wiki that also lists what kind of Wi-Fi chips are there and are supported. So yeah, thanks for sending the questions. Good luck with your meetups, and yeah, that's the end of our episode. Again, if you have something for us to cover in a future episode, send this to us at feedback@bsdnow.tv, and we have more material for next episodes.
Yep.